Hello, this is Mrs. Groves, and today I'm going to be discussing the NAQ.c standard. And this standard is to evaluate numeric expressions with exponents. I'm going to pass through this practice packet twice. The first time I'm going to do some selected problems, and then the next time I will go through and I will finish up and do all of the problems. I want to make sure that you know how to show the work so that you can meet this standard. So our level 1, which is does not meet, says to evaluate a numeric exponential power, clearly showing your work and circling your answer. So this is an exponential power. You need to write it as a product of factors to demonstrate that you understand that this is an exponent. So the base is 2. The exponent is 6. So that means that I'm going to have my base 2 repeated 6 times. Okay, so I have 2, 4, 6 2's. That's the work I must show. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. I should say that for this assessment, no calculator is allowed. If by chance during these practice problems there is one that has some large numbers, that was not my intent. On the actual assessments, the numbers will not require calculators. Okay, so now level 2 is partially meets. And this is the product rule. Evaluate numeric expressions with positive integer exponents. The exponents are positive. They're not fractions. Using the product property, clearly show your work, simplify and evaluate, and circle your answer. So the product rule is that when you are multiplying, same base, add exponents. All right. So the work that you show here is, you do not have to write this as a product of factors. You have to show how you do the arithmetic for the exponents that are involved. So here, the base is 5. The exponent here is an implied 1. I'll make this a little bit bigger. It's an implied 1. So our base is 5. We add our exponents. We get 5 to the third. And we say in our head, 5 times 5 is 25, times 5 is 125, and you circle your final answer. The third objective is the meets. And in this example, for these examples, I'm going to do 2 and 4. And so here, evaluate complex numeric expressions with whole number exponents, demonstrating the ability to use the product, the power, and the quotient properties. So here, I'm going to do number 4, is the power property. The power property, you notice, has parentheses. And so we have 5. And the work you show is, what is the arithmetic to handle these exponents? Well, I have to multiply the exponents to get 5 to the 4th. And we just said that 5 to the 3rd is 125. So 5 times 125 is 625. Now, as they said here, these are complex numeric expressions. So they will involve multiple properties. Now here we have a fraction. And what I recommend is you take care of the numerator and then you take care of the denominator. So in this case, the denominator doesn't need to be simplified. It's 6 cubed. The numerator, okay, there's an implied 1, 6, 1 plus 3. All right, and you have to do these problems using these properties. So I'm going to get 6 to the 4th over 6 cubed. So now I have used the product property. Now I'm going to use the quotient property. That means same base, subtract the exponents. 6, 4 minus 3 gives me an answer of simply 6 to the 1, which is simplified. This is going to be 6 to the 1, which is simplified as 6. The last criteria for is exceeds. And in this example, we are going to be doing complex numeric expressions, but the difference here is we're working with negative exponents. We're still using the product, power, and quotient properties, but read the directions. Clearly show work. Simplify the exponential expressions using only positive exponents. So negative exponents have to be changed to positive exponents. Evaluate and give answers as simplified, improper fractions, and circle your answer. So in this example right here, I am going to do number 4, which means it is the product property. So that is 3 negative 1 times 4 is 3 to the negative 4. And to get a negative exponent to become a positive exponent, we say to take the reciprocal. An easier way to say this is that we want to make the negative exponents, which are sad, we want to make them happy. And to make them happy, we just move negative exponents between the numerator and the denominator. So in this case, I'm going to take this -3. Okay, we're taking the reciprocal, so there's 1 in the numerator. So your fraction, if you put this in the denominator, you're always going to have 1 in the numerator. 3 to the 4th, 3 times 3 is 9, times 3 is 27, times 3 is 81. Your final answer is 1/81. All right? So those are the basics for the 4 criteria for this NAQ.c exponent standard. That is, now I'm going to go through all of these problems for you to make sure that you are successful on this standard. I do have the answers to this packet on my website. So if you understand these properties, then you can simply just go do these problems and then check them on my website. For those of you that would like a little bit more help, I'm going to go through and do these problems for you. So we're going back to the does not meets. The does not meets means you have to write this as a product of factors. 5 times 5 times 5 is 125. Okay, easy peasy. For the partially meets, remember this is the product rule, same base, add exponents. So here we have, don't forget your equal signs and making it so that it's clear to follow your work. Okay, we have to add these exponents. You have to show this step so that you show proficiency that to me, that you understand what you're doing. That is going to be 2 to the 6th. And that final answer is 64. 2 times 2 times 2 times 2 times 2. There's 6 2's, so that's 64. All right. So I'm going to start and I'm going to finish these problems. Remember I told you that you want to take care of the numerator and then the denominator. So the numerator is simplified, that's 3 to the 7th. The denominator, it's the same base, that's the product rule. So I add the exponents, 3 plus 2, which gives me 3 to the 7th over 3 to the 5th. And now we have to apply the quotient rule, which means we subtract the exponents. We must show this work. 7 minus 5 equals 3 squared, which your final answer is 9. Here, this is the power rule. We have to multiply 3 3 times 2 is 3 to the 6th. And I won't give you anything this difficult on your assessment, but 3 to the 6th is 729. Because remember, on the assessment, you cannot use a calculator. Okay, there are two ways to do numbers 5 and 6. I'm going to do them the two different ways. One is to use the power rule. And when I use the power rule, that means that I'm going to take the 4 and distribute it with the numerator and the denominator. So I'm going to get 2 times 4, which is 4 to the 6th. And in the denominator, that's an implied 1. 1 times 4, which is 4. Oops, bad math. 2 times 4 is not 6, it is 8. And 1 times 4 is 4. So now I apply the quotient rule. The quotient rule, same base. I have to subtract the exponents. So I have 4. 8 minus 4 is 4 to the 4th. And 4 to the 4th, you should be able to do that one yourself. I won't give you anything that difficult on the assessment, is 256. Okay. So for these two problems, there are two ways to do this. One option is to use the power rule. The second option is to use order of operations, which means parentheses first. So in this case, I have on the outside the 4, and I'm going to simplify using the quotient rule. 2. Quotient rule says same base, subtract the exponents. 4 minus 2, which gives me 2 squared raised to the 4th. Okay, now I use the power rule. 2 times 4 is 2 to the 8th. And 2 to the 8th is 256. So that's the work that is required. Let me make sure that you can see that all. Yeah, you can see that. All that work. Okay, so that's the work you have to show. So you can either use the power rule and distribute the 4 in this case, or you can use order of operations, simplify what's in the parentheses, and then apply the power rule. You'll get the same answer either way. It just matters which way you find it easier to do. And that was an 8. Okay, the exceeds. I'm going to go through these for those of you that want to exceed the standard. And basically all the rules apply, except that when you get negative exponents, you have to make them positive. So in this case right here, I have a negative exponent, I have a positive exponent. I'm going to use the product rule. I have 4, 3 plus negative 2 is 4 to the first, so that one was really easy. So the answer is simply 4. Here, okay, again, I have the product rule. There's an implied 1 there. So I have 3, 1 plus negative 3 is equal to 3 to the negative 2. But I cannot leave my answer like that. I cannot have negative exponents. So this is over 1. Take the reciprocal, which is 1 in the numerator now. Make this negative exponent happy by putting it into the denominator, 3 squared. And that's an easy answer, 1/9. So you can see that you don't need a calculator for these as long as you understand how, okay, just okay, so this is 1/9. This is 1 over 81. My answer key, if you go and you look at it, is incorrect. The answer here is 1/9. Okay. So here we have the power rule. 2, we multiply the exponents. 2 times negative 3, you must show the work, equals 2 to the negative 6. We want to make that negative exponent happy, so we take the reciprocal. So there's 1 in the numerator. And to make that happy, we put 2 to the 6th in the denominator. And that is 1 over 64. See, these aren't that bad. 2 more. Now, when you have fractions, take care of the numerator and then take care of the denominator. So I have this fraction here. I have 3 is my base. It's power to power 2 times negative 2. So that's going to give me 3 to the negative 4. I've simplified the numerator. Now in the denominator, I get 4, 3 times negative 1, which is 4 to the negative 3. Now I have to make these negative exponents positive exponents. So with my fraction, 3 to the negative 4 is going to go into the denominator. That's 3/4. 4 to the negative 3 is going to go into the numerator. That's 4 to the 3rd. And here we simplify it. 4 to the 3rd is 64. 3 to the 4th is 81. And I can't do anything to simplify it. answers are to be simplified improper fractions. Okay, we have one more. So again, work with your numerator first. So I have 4 to the negative 1. And then in the denominator, I have 2, negative 2 times 4. So this simplifies 4 to the negative 1 over 2 to the negative 8. I need to make these positive exponents. So 2 to the negative 8 goes into the numerator to be 2 to the 8th. And 4 to the negative 1 is in the denominator, which is 4, or 4 to the first. So my denominator is 4. My numerator is 256. I know that I can reduce that fraction. And in fact, 4 goes into 256 64 times. Okay. Don't forget to simplify. I hope you enjoyed this video and you meet or exceed the standard. And the answers are also posted in paper form on my website. Have a good day.